Thank you, James, and thank you everyone for attending. It's a very exciting floor to be. Let's get into it. So my name is Yuda Smirnov. I'm a red team and security researcher at Accenture Security Israel. You can find me on Twitter. I like learning and researching Windows and Active Directory, anything that's interesting. I do some development in C and C#, do some assembly. I like to surf and play tennis, and I'm also an ex-private investigator and ex-detective in the military. And even though I was an ex-private investigator, I mean, there's still a lot of mysteries that I'm having a bit of a hard time with. That's me falling from the surfboard. So, yeah. Let's get into it. So today, our agenda for today, we're going to have a bit of an introduction to Windows Hello for Business. We're going to talk a bit about the WebAuthn API, which is the underlying mechanism for authentication, kind of, for Windows Hello for Business. We're going to talk a bit about my investigation and about proxy phishing, and finally some mitigations. So let's get into it. Windows Hello for Business, or WHfB for short from now, because it's a long phrase, is considered a phishing-resistant authentication method. And I kind of discovered a way to phish Windows Hello for Business by way of a downgrade attack. We're going to see exactly how it plays out, but before we talk about Windows Hello for Business, we should talk a bit about Windows Hello. Windows Hello is the authentication mechanisms that you might be familiar with from Windows. It allows you to use a PIN code to authenticate your device, or use facial recognition, or fingerprint, or PIN code. And the way it works is by utilizing something called the TPM, or the Trusted Platform Model. That's located on the motherboard or on the CPU, and it stores cryptographic keys directly on the hardware, meaning it is not in the hard disk, and like the file system shouldn't have access to that. So this is just a bit of an overview so we can kind of understand how it works, because it's a bit needed. So first of all, to use Windows Hello, you need to enroll to Windows Hello. So you create a PIN code, for example, which is hashed, and then there's a lot of magic that's done to it, but it gets stored in the TPM. Now, when you want to authenticate to your Windows device, you provide the Windows Hello PIN, and that is kind of sent to the TPM. Now, the TPM performs the verification and compares it, does stuff, and if all matches, then you get access to your device. Now, Windows Hello for Business is kind of the extension for it. It's the kind of enterprise way. Basically, it allows you to use your local Windows Hello mechanism to authenticate to cloud applications. And it looks something like this. So when you go to the Microsoft portal to authenticate, you can click on the sign-in options, and then you can click on the box to authenticate using Windows Hello for Business. Now, when you do click on that, it's going to look something like this. So it's going to have a pop-up, like a Windows security kind of box, and you're going to select a credential. And once you do, you need to prove your you by either a fingerprint or a PIN code. And then you will have access to the Entra portal, for example. A quick note on that is, apart from Windows Hello for Business, there is also FIDO keys. So they kind of act as a replacement for the TPM's role in the authentication part, meaning they can store cryptographic keys on them. They have many names. Some call them YubiKeys or security keys, passkeys, but we're going to stick with the term physical authenticators, because that's the term described in the WebAuthn API specification. So, yeah. Another thing I want to quickly cover is the default authentication. So today it is no longer the case. Microsoft changed it, and it's good that they did. But when you used to perform successful authentication to Azure, if it was, for example, using an OTP code, then the next time you would want to authenticate to Azure, and you enter your kind of email and click on Next, then it would prompt you to use that authentication mechanism, even if you are enrolled to stronger kind of authentication. Today, the default authentication is the strongest one available, so it's good that they actually did that. And it looks something like this. So you you enter your email, click on next, and you know the rest. Now, you might ask yourself, it's just the PIN code. I mean, can't we phish that password too? I mean, what's so secure about it? And the answer is not so simple because of the WebAuthn API. And we're going to understand what happens now. We're going to see what happens when you try and phish someone who uses Windows Hello for Business if you set everything up correctly for the phishing framework. So you go to the attacker's website, you put your email, click on next, and then you will get this kind of message. This is like the Windows box we saw before, but as you can see, there are no credentials here. And if we take a closer look, we see that it says attacker.com on the domain, and it's very interesting, and we're going to see exactly why it goes like this, but this is the general thing that happens. Now, I said a few times the WebAuthn API. Let's talk about it. So the WebAuthn API is supposed to protect you against phishing. It's supposed to reduce the impact in the case of a breach. And it's supposed to protect against password-based attacks. It does so by enabling the use of strong and scoped credentials, which are public and private key-based. So there are a few mechanisms for the authentication, and we're going to go through them so that we can understand how it works better. So first of all, there's the challenge, or a nonce, which is just a big string that's valid for a few minutes. It is generated by Microsoft, for example. And this nonce needs to be signed using the appropriate private key. It is either stored in the TPM or in the physical authenticator. We're going to see exactly how that private key gets to the TPM, but just keep this in mind. The signature is produced by encrypting the challenge that we just spoke about with the private key. And it does so by having your browser kind of interact with the operating system. We're going to see exactly how that also comes into play later, but keep this in mind as well. Then there's the origin check. So just a quick reminder, the origin header is defined as the protocol schema, the host name, and the port. And it is implemented by the browser, and it is not something that the web application can supply to the client, meaning a web application cannot just come to a user and say, hi, I'm Microsoft.com, and please treat me as such. No, it is determined by the client itself. And we will see that this is also checked by both the client and by the server. Last but not least is the assertion. So the assertion is just the name for the entire package that gets sent to the server, which contains the encrypted challenge and the signature and everything like that. And it is just a big URL encoded JSON, which we have just seen a few slides ago. And if we dive into the client data JSON, it's just the challenge and the origin that are also being sent. And yet, I mean, why is it so secure? And to really answer that, we should talk now about the architecture. So first of all is the registration. You have to enroll to Windows Hello for Business before you can use it to authenticate. And a quick note here, for Windows Hello for Business specifically, the registration goes a bit differently, but the end result is still very much the same. And this is how it goes for FIDO registration. So first of all, you have to log in with username or password, and this might be the equivalent of joining or registering your device to Entra for Windows Hello for Business. And then you will choose to create a new credential, for example, a FIDO key if you plug that physical authenticator to your device, or if you just want to enroll to WHfB. Then what happens is like a script will be served to your browser, and that will utilize the WebAuthn API that's implemented in the browsers in most like modern and like popular browsers, and it utilizes something called the client platform. The client platform is comprised from the user agent header and the device itself, the laptop and the mobile device, whatever. So it uses the client platform to connect to the authenticator, either the physical authenticator or the TPM, and it will request an authorization gesture, for example, your fingerprint or a PIN code. And once you provide that, a new credential will be created. Now, what's this credential? So it is a public key and a private key that is just a key pair. And the private key will be stored in the authenticator, while the public key will be sent to the server along with some metadata. Now, if you recall a few slides ago, you might remember that the WebAuthn kind of promises to reduce the impact in a case of a breach. And we can see here it kind of lives up to this, because if the server contains just public keys, and someone were to breach it, then the attacker would only have a bunch of public keys and not the private key. And this means that the attacker cannot use it to impersonate other users or take it offline for brute force attacks, things like that. Now we know how the private key kind of got to the TPM or the authenticator. Let's talk about the authentication process. So first of all, when you choose to authenticate using the WHfB, a script will be served to your browser. The browser will request a nonce from the server. And once the server returns the nonce to the client, the challenge, it will use the WebAuthn API to interact with the client platform, which will request hardware authorization. Once you authorize, for example, provide your PIN code or the fingerprint, it will search for relevant credentials within the authenticator, within either the TPM or the physical authenticator. And I kind of wanted to illustrate it with a cute picture of the TPM. I hope you like it. So the TPM can hold many, many credentials. For example, you can see credentials for user 1 and user 2, 3 and 4, for Microsoft.com or GitHub.com. And the WebAuthn API will ask something like this. It will ask, what credentials are available from Microsoft.com? Now, what is Microsoft.com really derived from here? Well, that's the origin we just talked about a few slides ago. So the origin, being a client-side protection mechanism, is not something an attacker on a web server can interfere with. So it's good that really you can see how the client checks the origin in this part. So once that is done, for example, user 1 and user 2 are the credentials that a user can use to authenticate using FIDO authentication or Windows Wallet for Business. So that's good. And it looks something like this. And if you recall, we saw beforehand the attacker.com domain, but if we were on login Microsoft.com, we can see how that is kind of connected to the domain itself. So we take the challenge and we encrypt it using the appropriate private key to create a JSON. That JSON is just the assertion we also talked about a few slides ago, and that is returned to the web application server. Now, the web application server will perform some checks here. It will perform some verifications on the signature, on the origin. It will check, is that me, is that not me? It's important stuff. And once all is done, we will get access. So now we know a bit about the WebAuthn API, and we can start talking about my investigation. So I started with the assertion, which, as we remember, it looks something like this. I tried signing the challenges using different private keys. I tried intercepting the challenges themselves using different challenges, modifying the origin, trying to modify it from attacker.com to really login Microsoft.com to see if there's any failure in that case. And the answer is no. I banged my head against the wall and nothing came out. So I decided to take a step back to what happens when you click on the face, fingerprint, or security key kind of box, or when you put your email and click on next. And this is the request that we see when we click on that. And if you're sharp, and well, it took me a lot of time to figure this, but there are two interesting parameters here. So there's the isFidoSupported parameter, which is, I think, a dead giveaway, and the user agent, which, if we recall, according to the spec, it kind of comprises the client platform. So by changing the isFidoSupported from true to false, we could basically downgrade the authentication from Windows Hello for Business, which is secure, rather, to something that is not secure and something we can phish using common phishing frameworks. The same can be done with the user agent header, but well, today at least you cannot modify the isFidoSupported parameter. Microsoft fixed that. But still the user agent header kind of works. But it is just client-side defenses. I mean, since this is just JavaScript running on your kind of local browser, you will always have the ability to interfere with it. So on the mitigations, we'll focus on something that's more bulletproof or something that's more definitive for this. So just a quick demonstration, using a Burp Suite, a common proxy, we put our username, and then we intercept the request. We see the isFidoSupported and true. We swap it to false, and then our authentication gets downgraded. And then we get access to the Entra portal. So now we know about that, but I wanted to really take what I discovered and do it kind of for a massive scale. I wanted to not just use a proxy and like have it end there. So first of all, in case you don't know how proxy phishing works, so a legitimate authentication flow might look something like this. You send a request directly to Azure and get the response from Azure back to yourself. But if you are a proxy or an attacker in the middle who set up your own server, you can send phishing links to users and then have them sign into your application, which proxies Azure. So they send the requests to Azure, and the responses from Azure are returned to the malicious server and are then sent back to the user. So the attacker can kind of stand in the middle and just capture this credential, capture these cookies, and with these cookies, it can bypass, for example, common MFA or authenticator kind of authentications, because we can just take the cookies and import them to our local browser session and hijack that session. I chose to use EvilGinx, a great framework made by Kuba Gretzky. If you do not know it, then you should definitely check it out. It's a great framework. And I wanted to show you how it kind of looks like when you set it up. So you're going to see this is just the regular Microsoft page, and really it's a one-to-one replica. I mean, you cannot really tell it is not a phishing page because there's no HTML or CSS involved here. It's just a proxy for Microsoft.com. If Microsoft did some rebranding sometime, well, it would still look exactly like how Microsoft rebranded it because it's just a proxy. The only real way to tell is by the domain name. In this case, it might not be so obvious, attacker.com, but that's a malicious domain. But in all seriousness, attackers can use type squats and try and modify Microsoft, swap an O for a 0, and try to look like Microsoft. So to automate the entire thing, I had to add just a bit of support to the EvilGinx framework to support some JSON parameters. And with that, I could be able to craft something called a fishlet. A fishlet is just a template for EvilGinx, which we can specify that we want, for example, to proxy Microsoft.com. And for example, we want to capture the specific request. You can see in the red box the get credential type request. We find the isFidoSupported parameter and switch it from a star to false, and this way we can achieve the downgrade. So let's see a short demonstration. So you go to the attacker's website, you put your username, and then you will be downgraded. So you put your password, and you get the OTP code instead of Windows Hello for Business. And then we can just redirect the victim user to office.com because we don't care what happens with him next. From the attacker side, we can see the username and password, obviously not the real credentials, and we can see the cookie. with that cookie, we can actually, even if the user has MFA enabled, we can just take that cookie and import it to a session of our choosing, and then we can have our initial access to the target tenant, for example. Now for some mitigation strategies. We're gonna use conditional access policies. Specifically, we're gonna use authentication strengths. It's something Microsoft introduced a while back. And with it, we can require authentication strengths. Specifically, there are 3 authentication strengths. What interests us is the phishing-resistant MFA option. So we want to create a conditional access policy which will require users to use authentication strengths of require phishing-resistant, meaning we do not want them to be able to sign in, for example, to all cloud applications using lesser secure like passwords and MFA, anything like that. Now, we should create an additional conditional access policy because, well, suppose right now an attacker cannot authenticate or downgrade the authentication because they have to use they cannot use it to authenticate to all cloud applications, but they can use it to register new security information. And new security information is basically the MFA or the OTP or new authenticator or even FIDO key. So it would be kind of pointless if we had the previous conditional access policy without something to actually limit the ability to register security information. And now, how would we do that? I mean, we still don't have a Windows Hello for Business. I mean, we cannot limit that to phishing-resistant authentication only. So we can, for example, require that anybody who wants to register security information needs to have their device joined or registered. So an attacker is less likely to have a device already registered in the tenant, but it can still kind of happen. And that's demonstrated by Dirk Jan's great talk lately, if you haven't seen it, about like phishing for primary refresh tokens. And basically, what that means is we should also take a look at limiting the ability to register or join devices, meaning not all users should be able to do that. Unfortunately, I don't have time to cover all of that, but it's definitely something you should also take into consideration. The other recommendation by Microsoft is to also enable MFA for all users. So obviously, this won't block proxy phishing attacks because you can just capture the cookies. But MFA is better than no MFA, and it will certainly make an attacker's life that much harder. So it's definitely something to consider if you do not have some conditional access policy like this. All of this goes without saying. Don't deploy stuff straight to production. I think you should definitely do some testing before you just push things like that to production. Let your users know that things like that are coming, and don't just push it all because you might burn the house down, and that's not good. Just a final demonstration. What happens when you try and log into a phishing site which has the conditional access policies in place? You enter the password, you are downgraded, but you are required to use Windows Hello for Business authentication. And at this point, the attacker will be sad because he couldn't get any credentials from your tenant. Just some info about the report timeline. I reported this to Microsoft on September 2023, and they said they fixed it on November 2023, and you saw some changes, like something that was possible when I researched this, and now it is not so possible. So, takeaways. We talked about Windows Hello for Business, why it is secure, why it is phishing resistant because of the WebAuthn API. We talked about the downgrade attack vector. I mean, even if you have passwordless or Windows Hello for Business for your users, if you do not enforce it, then what's the point of it? And we talked about how to mitigate this using conditional access policies. So if we just recap quickly, you should enforce the phishing-resistant authentication for all cloud applications. You should limit the ability to register new security information. And you should also limit the ability to join or register Entra devices to your tenant to actually be a bit more secure against these kind of attacks. The GitHub repo with the slides will be available here if any of you want to check them out later. They're also available on the Black Hat website. Any questions? I think I can take them now or off stage if you have any. So thank you all for joining me. And